today we'll be doing a small lesson. How many of you like to study about atoms? Anyone interested? Right? So chemistry is about studying reactions or studying different atoms, and also we are going to know like what is there in an atom, right? And what are these molecules? Sometimes we use different terms, right? Molecules, compounds, right? So those we will learn under chemistry, and there are like interesting reactions also, and there are experiments. So I think we should do more experiments than a lot of theory, right? So today we are going to do a small experiment. So everyone will be will be doing a small experiment. So there are so many different experiments in chemistry syllabus. So when you are in grade, how many of you are in grade 8 now? Anyone from 7, 6? Okay, right, good. Right. So when you're in grade 8, when you like know initial parts about chemistry, it's very easy when you start your O levels to do chemistry, biology, physics, right? So chemistry is there's a lot of interesting reactions also in chemistry that we can do a lot of experiments using them, and there are color changes. Now in chemistry we will learn when some reactions happen, there are certain color changes that happen. So using the color changes, we can even identify these particles like atoms, ions. We can identify. So today we will initially study about atoms, right? Then we will do a small experiment which is also related to our syllabus, right? Initially, study a little bit about atom, because we are going to study about different atoms and the structure in the atom. So let's go to first topic now. Take the book, take the writing book, and you can write the topic atom. Right, guys. Now, if you take an atom, so atom consists 3 main particles, right? So in an atom, there are electrons. So these electrons are negatively charged particles, which are really important for an atom. And also we have protons. Protons are another type of particles. So we have electrons. We can use E for electrons. And we put a negative sign there because electrons are negatively charged, right? And there are protons. So protons are positively charged particles. So we can. Yeah. So I'm gonna explain. So in atom we have 3 main particles: positively charged protons, and also there's another particle called neutron. They are neutral. So in an atom, we have 3 different particles, right? So electrons, protons, and neutrons. So you can write down these 3. Now, guys, when we take anything, right? Everything is made out of these small particles. We call them atoms, right? So in my body, there are so many millions, like billions of atoms, right? So these atoms combine and they make like big molecules and everything. Now, if you take my mobile phone, right? It has so many atoms in it, combine small particles. We can't see them from naked eye. We can't. But if you like, you can actually see atoms through electron microscope, right? So which we don't have now, right? It's a very expensive one. So atoms are the smallest type of particles that we find, but inside the atom there are more particles, right? So these 3 particles are there: electrons, protons, neutrons. Now let's draw a structure of an atom. Now, as I said, no one can see one atom, single atom. But when there's many atoms, you can see that, right? So this is many atoms. You can see this because so many atoms combine. But here we have small atoms. We can't see them because they are not combined. Once they combine, once they're close to each other, we can see them, right? So now we first of all we will draw structure of an atom. So let's write down a small note here. An atom consists of three main particles. Electrons, protons, neutrons. What are the particles? We have electrons, protons, and neutrons. Right, now if you take an atom and let's see how these electrons, protons, and neutrons are arranged in the atom, right? So in the atom, guys, there's a central area, right? So let's take an example of an atom. The middle area of the atom. This middle area of the atom is called nucleus. Nucleus of the atom, right? So this nucleus consists of only protons and neutrons, right? Electrons are not there in the nucleus. So in an atom, we have a nucleus. So I'll put a yellow color to nucleus. Right. So this is the nucleus. It contains only protons and neutrons. So now to symbolize protons, I will use plus charge and put a circle. Okay, that's how I symbolize protons. So to symbolize neutrons, I'm going to put a small circle like this. Circle without anything, right? So symbolize electrons, I will put E minus. Now I'm going to put some protons to the nucleus. So we can put like, let's say 2 protons, right? So 2 protons I put. Then inside the nucleus, now the thing is, guys, plus and plus won't attract each other. Particles, now if you take magnets, have you tried magnets? Sometimes they don't attract, they repel, right? So plus and plus can't attract. Like charges repel, right? But oppositely charged particles attract. Now when we put like 2 protons into nucleus, right? Now inside the nucleus there's a fight. These 2 fellows are fighting, right? They're repelling. Fighting means they are not attracting, they're repelling, right? They push each other, right? We also like to fight sometimes, right? So like that, protons also like to fight if they are with same charge particle. Now this is why we have neutrons. These neutrons, they are now. Sometimes people think neutrons. Why do we need neutrons in an atom? They are not doing anything actually, but they are doing something. They are inside the nucleus. They minimize the repulsion. So there's one neutron. There can be more than one neutron, right? So there are a certain number of neutrons. So neutrons, what are they doing? They are reducing the repulsion between the protons. So we can draw like an empty circle, a small empty circle, that is a neutron. So after I draw, you can draw the full diagram. Okay.
So for example, is this an atom?
No, that is many atoms. Many atoms. So it's, everything is made out of atoms. So that is so many atoms combined, right? So everything that we can see is a combination of so many atoms. But there are atoms we can't see one atom, but when they are combined, we can see. Right? Now, where do we put electrons? We don't put electrons to the nucleus. Right? Electrons are outside the nucleus. So they are outside the nucleus. So I put a different circle and then put an electron like this. So there are so many electrons. So let's put another electron. Right. So electrons are not in the nucleus, so we can mark now. They're outside the nucleus.
So
Yeah.
why have you put next to the E? Why have you put a minus?
Because electrons are negatively charged. Usually, when we write electron, we put a negative charge with E. Because electrons have negative charge.
Sir, negatively charged.
Minus charge. There are particles with charge, without charge. So electrons have negative charge, protons have positive charge. So those are the two charges we have, plus and minus. Only plus and minus. Right? Minus is opposite of plus. Get it? Right. Shall we draw? So this is the nucleus. This circle where electron will hang out, we call that shell. Right? So we have shells and we have nucleus. What do we have in the nucleus? What are two particles in the nucleus? Protons and neutrons. What is the charge of a proton? Plus. What is the charge of neutron? No charge. Right? What's the charge of electron? Minus. And where do they hang out? They are outside the nucleus in shells. Right? So we can draw it. No need. One circle is the nucleus, the other circle is the shell. In nucleus, we have protons and neutrons. In shells, we have electrons.
So how do the atoms get their colors?
That's a different lesson. It happens, atoms, in the sense, when they combine, they get different colors. There are different processes happening in the atom. The electrons absorb energy and go to different shells. So when that happens, they will be seen as colored compounds. So it's a different lesson, bit complex. We teach that in A-level class. The chemistry behind colored compounds. It's an interesting thing to learn, actually. Right, I welcome it. Right, right. Time is flying. No?
Okay,
Right. Also, we can write down here. We draw a small table. In this table, we need 4 rows, 3 columns. One column is particle, one column is charge, the other column is mass. particle, charge, and the mass. Right, so under particles, we have 3 particles in an atom, right? So 3 particles in an atom. So one is proton, the other one is neutron, the other one is electron. For protons, we can use symbol P, simple P for protons, simple N for neutrons. We can use E for electrons. When we write in short form, for an example, let's say you are writing a note, you can use short form P for protons, N for neutrons, E for electrons.
Paper.
Not in the paper, but when you write a note, you can use short form for certain terms. Yes, excellent. Yeah, electrons also repel. Why? Electron and electron can't attract. Why? They have same charge. So if I have electron here, I have another one here. It's very difficult. They repel. But if I put an electron and proton very close to each other, what happens? They will attract.
So then how is only electrons on the shell?
Very good. Right. So the thing is, even though the protons are there in the nucleus, they attract to a certain extent electron, not completely. Right. There is attraction here, but these protons are with neutrons, so they can't completely attract the electron into the nucleus. So initially, scientists thought atom is like this. That's a good question. So atom is like this. You have protons, you have electrons, you have neutrons in one place. Then they did some experiments, and then those experiments helped to find out where electrons are, and the electrons are not actually in the nucleus, they're outside the nucleus. That's because even though protons are attractive, they can't completely attract. There are certain properties in the nucleus that will not allow protons to completely attract the electron. That's why electrons are not in the nucleus, they're in different shells. Right, now we will fill this table.
Sir, can you repeat what you said? Your voice was it was breaking. Can you repeat what you said?
Yeah, what I said was in the nucleus, we don't have electrons, even though there are protons. These protons are there. That's because there is a certain attraction that can be given by protons. So electrons are not completely attracted into the nucleus. So electrons have no space in the nucleus. Okay?
Sir?
Yeah.
Now, in the shell, so you have put the electrons on like either side of the shell.
Yeah.
So on the whole shell, there are electrons, like in every part of it.
Yeah.
So you said electron and electron can't attach together. So then how is there like electrons together?
Yeah.
around
So
the whole shell?
yeah, in this case, there's only 2 electrons. Okay. So one electron in one place, the other electron in the other. So they won't collide. They won't repel them. Okay. Right. Now charge of proton is +1. We say charge of proton is +1. Charge of neutron is 0. No charge. 0. Very good. And charge of electron is
-1.
-1. So if you have 2 electrons, then -2. If you have 3 electrons, the charge becomes -3.
So now, if there are more than one neutron, so how many? What will it be?
Still 0.
Still 0. Oh.
Charge from neutron will be still 0. Because 0 into any number is 0, right? 0 multiplied by any number is 0, right? So,
Yes.
therefore, when you have like many neutrons, it won't change the charge of the atom. It will not have any effect on the charge. Now, there's a mass for each part. Now, here, how do we measure the mass? What is the unit usually we use?
Kilograms and grams.
Kilogram, right? So you tell your friend, Machan, I went to gym, I lifted 10 kilograms. Right? 10 kilograms is nothing, right? 10 kilograms. So your mother will tell, Buddha, go to the shop and buy some sugar. How many grams, Amma? So mom will tell 100 grams, 200 grams. So grams is what we use, or kilograms is what we use for mass, right? Mass of substance when we measure. But in chemistry, now we can't measure atoms with grams, guys. You can't put atom to a balance and measure the mass of one atom. That's not possible. The atom is very small and we can't even see. And the balance reading won't even change because we have balances that can measure up to certain decimal places, but not very small values, right? Therefore, we use a different unit for mass. It is called atomic unit. So that's therefore we don't write a certain unit. We just write a number. Relative mass of proton. Relative mass of proton is taken as 1. Again, it's not grams. 1. And relative mass of neutron is also 1. Neutron has mass. Electron is very tiny. This electron fellow is very tiny. It's like almost no mass, right? There is a small, like very small mass, but compared to proton and neutron, mass of electron is very small, right? So,
Like 1 kilogram.
not 1 kilogram. Again, it's not grams or kilograms. It's a different unit because it's very small. Okay.
Is it minus?
No, electron mass is not minus. Minus means nothing with it, right?
So it is 0.001.
Yeah, it's smaller than that. Okay, so we say it's negligible. Negligible. Very small.
So that means very small.
Very small. Very, 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 very small.
Is it any Y or E?
Energy. Very small. Actual amount is 1 over 1840 roughly. Actual amount. But in O-level class, we don't have to know that amount. Okay? We say it's very small. So when we find the mass of an atom, we don't count the electron mass. Yeah, you can write the value also. It's very small, it's that amount. But in the exam, you don't have to write that value.
So what's the limit of the mass?
Don't put anything. Right, now we'll do like this. We are going to take a small break. Right? Did you all get a break in the wireless class?
1 hour and half, 1.5 hour.
1.5 hour break. That's after wireless class, right? 5 minutes. During the wireless class? 5 minutes.
I didn't do bio class.
Economics? In economics? 1.5 hour.
Physics we got 2 minutes.
Only 2 minutes. Right. Anyway, we can take a small break. Now, during the break, don't go home and eat something and come back. You don't have time to do that. You stay here in the premises. You can go to Sumanati, sit down and get something to eat or whatever. But don't go outside of Sumanati. Just stay here. Right. But before we take the break, we'll do like this. Right. So let's close the book. Close the book. So there are students at home, they will also close their book. I trust them. I can't see them, but I trust them.
Questions.
We're gonna ask some questions. Do you like to answer questions? You like,
Yes,
right?
sir.
Not when
Yes,
I
sir.
answer question. I'm also scared of my mother. When I get a call, I answer quickly, otherwise. Some people hate questions, but in life, in exam, always they ask questions. Now, can I write when they ask, describe an atom? I hate this. I can't. I had to write an answer, right? That's why we learn. Right. Now, guys, it's a small question. What are the three particles in an atom?
Protons, neutrons, and electrons.
Oh. Protons, neutrons,
Neutrons.
Ah,
No. Protons, neutrons, and electrons.
Very good, very good. Now, raise your hand if you know the answer now, this time, okay?
Don't tell the answer that girl.
Right. Now, in atom, we have a nucleus. Now, nucleus consists which two particles? Anyone know the answer? Which two particles?
Sir, I'm raising my hand online.
Nucleus contains two particles. What are the two particles in nucleus? Okay, we'll give chance to one. Okay. Yeah. Protons and neutrons. Is that correct? That's correct. Super.
Yes,
Right?
sir.
Protons and neutrons. So electrons are outside the nucleus, inside, right? Right. Now let's see how much you know this. This one is a very difficult question. Right? So,
Before you ask that question, what was the mass of what is that? Starting with N very small.
neutron. Electron.
Electron.
Negligible.
Right?
So you say negligible, zero.
Zero. I'll say zero.
Right. Now, this is a very difficult question. Hardest question ever. Here's the thing. If you correctly answer, you get $1. But if you give the wrong answer, you give me $1.
Then you get so many dollars. That's not fair.
So I asked a very difficult question and $1 extra tax. No, it's like dollar rate now. I saw it 366 something. He's thinking of earning that dollar and getting something from what is this? Anyway, I was kidding. I don't have any dollars to give to them. People can see. Right. Anyway, let's see how many people can answer this difficult question. What is the now? If you know the answer, raise your hand. Okay. Those who are online also can raise their hand. There's an option in the Zoom chat. Right. Okay. What is the charge of an electron?
Minus
What
one.
is charge of an electron? Okay.
Sir, can I
What is-
tell the answer?
Okay.
Please choose me.
Okay. You tell me. Minus how much? Minus 1. Minus, yes. So electrons have negative charge. Very good. Electrons have negative charge. Right? It's not hard. It's very easy, no? Even Kale Mudra can answer these questions now. He can hear.
We ask him business.
Yeah. When you go to Sumanati, ask them what is the charge of an electron. Right? They will tell because they can hear. So even Kale Mudra can say the charge of electron is -1, right?
Take your student to
Don't ask them, man. They don't know.
They come to say you're trying to test our skills.
Right. What is the charge of neutron?
So can I tell?
You can tell.
0.
0. No charge. Right? So protons.
The neutral.
Yeah, neutral. So electrons have -1 charge. Neutrons have 0 charge. No charge. What is the particle? Sorry. What is the charge of a proton? Easy one, no? What is it? Yeah.
Sir, can I tell
Plus
the
one.
answer, please? Sir, can I tell the answer, please?
Yeah, then
+1.
+1. Right? So electrons have positive charge. Positive. Electrons have negative charge. Sometimes I think students are sleeping inside. Some students have ability to open their eyes and sleep inside. Right? So I check them like that. So electrons are not positively charged, they are negatively charged, and protons are positively charged, neutrons don't have a charge, like zero charge. Right. So, right, guys. So today we're going to do a small experiment quickly. Right. Before we do the experiment, there are certain apparatus that we use in the chemistry lab, right? And also in this bag I have this something really important. The safety glasses, right? So we use safety glass because there can be explosives, sometimes accidents. We don't know, like sometimes in this section, don't worry. This experiment is not very crazy. There are crazy experiments also where we have to wear safety glass to protect our eyes.
Where can we do that crazy?
Yeah, crazy experiment next week we can do, right? So you can see if you look at this side, yeah, can you see something on the ceiling? Right? So we have a during the class. Right, so we have wear safety glass. So next day. Okay. Right. So we can give. Can you all take one and give some to others as well? Right. Right, now also there are certain apparatus here. So this is called beaker, right guys? What is this? Beaker. This is a beaker, right? So this is called a beaker. So I'm going to give like one beaker to every row, right? We'll give one beaker to every row. Right, guys. Here I'm giving you a beaker. Give a beaker. Too small. Right, so we can give like we have certain beakers, so we can actually, yeah. You three can share like one. You three can, so we can give one beaker then. One beaker, yeah. Okay, you took it. Right, now these beakers are made out of glass, so they are brittle, right? That's right. They will break, so don't hit anyone with a beaker, right? So usually we put solutions like liquids into these beakers when we do the experiment, right? So what's the name of this apparatus? Beaker. Right. And there are other different types of apparatus we will learn. We have one lesson for apparatus. Okay. Now just introduce this apparatus. This is called the conical flask. Conical flask. Conical flask is a flask, but we call it conical flask. And this is a volumetric flask. This is also flask. We call it volumetric. We want to make solutions accurately in this one, but I'm not going to use this in the experiment. Right. Now our first lesson is we learn about atoms. Then next day we will learn about different physical changes, like physical states. Like we have liquids, right? Have you seen liquids? Yeah, we have liquid, right? And we have solid, right? So solid. There are solids, liquids, and then third one is gas. There are gases. Right? So you can say that's gas here. Yes, that's gas. I can see. Inside. Right? You can't see it because gas particles are very small. Now, we will learn about. Now, have you heard about boiling? Your mother said, "Buka, boil this. Boil this water." That means we boil it, but when we boil it, when we heat the liquids. Liquid goes from liquid state to gas. When liquid becomes gas, that's boiling. Okay? And then when solid becomes liquid, we call it melting. Butter is melting. Why do you keep it outside? Put it in the fridge. Right? Mother will always tell us. Right? Because butter is a solid, it becomes liquid. Right? When it melts. So melting is that solid becomes liquid. Then opposite also will happen. Now when liquid becomes gas, we call it boiling. Then gas also can become liquid, opposite. Condensed, right? You might have learned. Condensing is the term for that. You will learn the term properly. Then when the liquid becomes solid, we call it freezing. Freezing is when the liquid becomes solid, like water, liquid water. When we put to the freezer, what happens? It becomes ice, right? Ice is solid state of water. Then there is another change. Solid, now usually solid melts and then it becomes liquid, right? Then the liquid becomes gas. That's how it goes to gaseous state. Solid become liquid, liquid then become gas. But there is a scenario where the solid directly become gas. Sublimation. Solid directly become gas. We have that in the note, right? Sublimation. So we're gonna experiment sublimation today. So I have this bit of hot water and no, I'm not going to kill them. Yeah, I'm not. How many people have seen carbon dioxide? Have you seen carbon dioxide? No? Carbon dioxide is there. See? You can't see, no? You're blind. You can't see because they are. Last one. Carbon dioxide we can't see. That's true. Right, guys. Now also we need gloves. Quick. Can you take one glove? Put gloves. Yeah, this is not the glove that we always use. I could find like rubber gloves today. Huh? It's fine. Just one. Right. Very good. Good. Talk. Right. It's fine. Yeah, I don't know. We have the remote, right? So we have a lot of experiment. I'm going to combine theory with experiment. You see, there are more interesting experiments. So today we are just doing one experiment. Right. Now, guys, today we have carbon dioxide. So can I also get a one plus? Right, now carbon dioxide, you can turn carbon dioxide into solid. So today I have wrote it. It's very cold, okay? Yeah. This is compressed carbon dioxide is solid. So already it is becoming gas. So this is called dry gas. So you can see solid, right? Solid without melting or without going to liquid state directly become gas. So this is called sublimation. Right? So I'm going to give like pieces to everyone. Yeah, don't worry. Yeah, there are, I can give the number. There are places where you can get this. I got it from Colombo 50. There's a place. They are like always open. Right. Can you comment the next one piece of carbon? Yeah. Yeah. It takes all the heat from our hand. Okay, put it to the lake. Okay.
Can you keep it on the table?
Yeah, you can. Right. So we will put on to this. Now what I'm going to do is because there's a noise. Right, guys. Now what I'm going to do is see. I'm going to put some hot code. I think this is 40 now. So when I put hot code, then heat energy will translate to the solid, and solid will start to become gas.
Sir, what is in the beaker?
That's it. Right. So this is carbon dioxide gas. Can you also put some?
Let's do one by one. Then we have slowly done.
Yeah, because it's already becoming gas with the pressure. Translate. Keep on. Right? So that's carbon dioxide, can you see? So, yeah. I think there was 18 years. There was 18 years maybe. It is 8 years. We can put some.
Sir, can you put more water if we put another cube?
You can put some.
Sir, what was in
We are taking carbon if you want. Right. Next, now with this experiment, I teach two main things. One is this is an example of solid directly became gas. Like we had a water to just to heat it, otherwise we could have heated it like that. You can do like that also.
Sir, can you open this?
Oh. If we have the rubber glove, we would have filled the glove with gas. We can like put the glove to the beaker like this. Like that. This one has. If you need more pieces, you can take more pieces.
Sir, what did you put in the beaker?
Sir, can you put more water here?
Over there. It's okay. Our data is not toxic, but not too much. If you need another cube, come.
Sir, put another piece for us.
Right.
Sir, look at this.
Guys, I can't take this off. Why don't I take this off? It will supply complete. Take some. Did it go? This is called dry ice. So carbon dioxide solid is called dry ice. You can show the video.
Sir, can we get another piece of gas?
There.
We'll let it
This one, but it is.
Can you put another?
color doesn't come, no? It'll come in a bit. The ice is right here. Yes, already.
So carbon dioxide is a colorless gas, but because there are so much gas, it's the white color, right? But carbon dioxide is colorless, right? And another thing, you will notice something. Can you answer this question by looking at your experiment? Is carbon dioxide a heavy gas? Nice. You can show this one. Is carbon dioxide a heavy gas or a light gas? Very, it's heavy. How do you know it's heavy?
Because it's on the ground.
It falls to the ground.
It's a heavy gas.
It's a heavy gas. Did you notice that? Carbon dioxide, it falls to the ground. It doesn't go up like hydrogen. Johnny, more please. There's more here. You can. Then it will quickly become that. Same thing. So we need energy. It will quickly become that. Good job, good job. Nice. Suraj got green.
No, drink it.
This looks like a waterfall.
It's not
So
seen.
look at this.
Yeah. Excellent.
Wow.
Take a picture. You have more?
Yeah, but the camera quality is horrible.
You have your. If something happens, I'm not responsible. Right. So next day on we carbon dioxide is not poisonous. Don't put it. It will burn your tongue.
Wow, so look at this.
Look at this. Sure. So this is called sublimation. Sublimation is solid becoming gas directly. Do you need more? Yeah.
I touched it. It's happening.
It's like I
So I'm going to take some pictures. Nice. So you put some color.
Is this too much water?
So it's a lot of carbon dioxide. Nice. Stop.
Stuck to the beaker.
Huh?
This carbon dioxide is stuck to the beaker.
Yeah, that's because it's frozen now. Right. So again, the process is known as sublimation. Sublimation is when the solid directly become what? Solid directly become gas. That is sublimation. And we also learned carbon dioxide is a heavy gas from this experiment, right?
Can we do another 3 experiments next week?
Yeah, definitely. Next week we will do another experiment, right? If you can come physically, it's better. So you can also get in. Okay, we can. Okay, so those who have joined physically can carry out. We can, yeah.
Shall we have this?
So, okay.
Can we get that beaker? It's like something.
This one, huh? But the opening is very small. Okay, those who have joined physical online can also try and join physical next day. So we will see you all next week. Thank you for joining today. Bye bye.